This video demonstrates the configuration of the stack area for an RX microcontroller using the CCRX compiler and E-Square Studio. This video covers the following topics. First, let's begin with an overview of the stack area in an RX microcontroller. RX microcontrollers offer two stack methods to choose from. The two stacks method employs two separate stack areas. The one stack method employs only one stack area. The two stacks method uses separate stack areas for main routines and interrupt handlers. The stack area for main routines, known as the user stack area, is allocated as an SU section. The stack area for interrupt handlers, known as the interrupt stack area, is allocated as an SI section. The user stack area is managed by a stack pointer called USP. The interrupt stack area is managed by a stack pointer called ISP. Typically, users manipulate these stack pointers through register R0. If you access register R0 during main routine execution, register R0 functions as USP and switches to ISP upon an interrupt. It reverts to USP when the interrupt concludes. This switching is performed automatically by the hardware, ensuring that R0 is always set to the appropriate stack pointer, even though two are in use. The one stack method uses only the SI section, which is shared between main routines and interrupt handlers. Access to register R0 is consistently to the ISP, with the interrupt handler's stack frame being created from the stack pointer position at the moment the interrupt occurs. The one stack method is more memory efficient compared to the two stacks method. The CPU mode should also be considered when selecting the stack method. RX microcontrollers feature two CPU modes, supervisor mode and user mode. When an application requires switching between these modes, only the two stacks method is available. If solely supervisor mode is employed, both stack methods are available. The following is an example configuration utilizing the two stacks method. Let's start by configuring the stack method and size. If using the Smart Configurator, open the project's SCFG file and select Components, RBSP. Configure user stack setting to 2 stacks, and set user stack size and interrupt stack size as desired. Ensure the number is a multiple of 4. Finally, click on Generate Code. You have now established the stack method and size. If not using the Smart Configurator, begin by editing resetprg.c. Set bit 17 of the PSW init macro to 1. This macro represents the PSW value in the startup routine. Setting bit 17 to 1 changes access to register R0 in the main routine to USP. Next, edit stack sct.h. Enter the size of the user stack area after SU equals and the size of the interrupt stack area after SI equals. Ensure the number is a multiple of 4. You have now configured the stack method and size. Next, let's proceed to set the allocation address of the stack area. Navigate to Project, C++ Project Settings. Select C++ Build, Settings, Tool Settings, Linker, Section. Click the button on the right to open a window for specifying section allocations. This is an example of the SU and SI sections allocation in consecutive order, starting at address 1000. Click OK once you finish editing. Click Apply and Close. You have now set the address of the stack area. Note that the compiler automatically inserts the initial value settings for USP and ISP into the startup routine, so manual entry is unnecessary. Congratulations! The RX stack area is now configured to your specifications.